Hey friends, in this video I'm going to show you how to solve systems of linear equations. Now, there are several methods for solving a linear equation, and I will take you through them one by one. So the first one is substitution, and I already have our linear system here, and I've marked down the two equations with 1 and 2. So what you'll want to do is take one of the equations. I'm going to take number 2, and then we'll want to solve this for x and set x equal to something else on the other side. So if you subtract 6y from both sides, you get x equals 20 minus 6y. And now you can plug that into the other equation because you see x is equal to 20 minus 6y. So this is number 2. Now you plug this into number 1, and you have 2 times 20 minus 6y plus 3y equals 13. And now, using some distributive work, you get 40 minus 12y plus 3y equals 13, which is 40 minus 9y equals 13. Now you've already made it this far, and you can just subtract 40 from both sides, and you get negative 9y equals negative 27. Then you divide both sides by negative 9, and you get y equals 3. Now you already have one of the variables, and you'll want to plug that into another equation. For example, I'll just take the first one again. 2x plus 3 times 3 equals 13. Now you can solve for x. You get 2x plus 9 equals 13. And if you subtract 9 from both sides, you get 2x equals 4 and x equals 2. And now you have your answers, y equals 3 and x equals 2. And that's how you solve a linear equation using substitution. Now, the second method is addition, or, as I should probably write here, addition slash multiplication. Now, the first thing you'll want to do is cancel one of the variables, and you do that by multiplying this by negative 2 and then adding the equations together. So in total what you'll see is this. Okay, so we're multiplying every coefficient and number here by negative 2. Then just write the second one down as usual. And now you'll want to add the two equations together. What you'll get is negative 3x, and the y term cancels out just like we wanted it to. And then on the right side, you have negative 6. So in total, you have negative 3x equals negative 6. This is a pretty easy solve. You'll just want to divide both sides by negative 3, and you get x equals 2. So now it's, again, pretty simple. You already have one of the variables. And if we plug it into either one of the equations, I'll take the second one, we get 2 plus 6y equals 20. If we subtract 2 from both sides, we get 6y equals 18. And we just divide both sides by 6. And you get y equals 3. And with that, we once again have our two answers. And that's how to solve a linear equation using addition slash multiplication. Now, our final method is Gaussian elimination, which is slightly more complicated, but it's especially helpful for bigger systems. But in this case, to show that it works, I'll use it on this equation here. So what you have to do is take a matrix like this. This is a matrix. And then you take all of the coefficients. So for example, for 2x, we have 2, 3, and 13. This would be the first row. Now you just take all of the coefficients from the front here, 2, 3, 13, you see it. So now, just imagine there's a 1 here, then you put a 1 here, and 6y, and 20. So this is your matrix. And to solve a linear equation like this, what you have to do is draw a staircase. Now in this case, it looks like this, but for bigger matrices, what you have to do is you put the staircase under your first value and then keep going until you reach the bottom. Now, here there's going to be something. You don't know what it is, and here there's also going to be something. Now, the goal of all of this, hang on. Yeah, there's something up here. It doesn't have to be 0. Now, the goal of all of this is to get the values under the staircase to be 0. Everything else can be whatever, but everything under it has to be 0. And if we do that here, we'll want to get this 1 to become a 0. And the way we do that is we take minus 1/2 times this first row. So, for example, here, 1 minus 1/2 times 2 is 1 minus 1, and that's 0. So that's what we wanted. Now here, this is our next matrix. The top row stays the same. The bottom row, do this, because now you have 0 here because of the change. And you have to do that for every other value. So in this case, the values get a bit messy. That would be 6 minus 1.5. So 6 minus 1/2 times 3. And then you get 4.5. And then finally, 20 minus 1/2 times 13. So this is the process you have to go through. 20 minus 1/2 times 13 is 13.5. And now you're basically ready with all of the matrix stuff. You put this back in linear equation form. So the top row is still 2x plus 3y equals 13. But the bottom row is now 4.5y equals 13.5. Okay? And basically now it's easy. You solve for y. 4.5y equals 13.5. So you just divide both sides by 4.5. And then you get y equals 3. And from here, you know how it goes. 2x plus 3 times 3 equals 13. 2x plus 9 equals 13. You subtract 9 from both sides. And 2x equals 4. And x equals 2. So here we have our two answers again. So basically, oversimplified, what we did here was we turned this into a matrix where all of the coefficients here are the values, and then we drew a sort of staircase and we made everything under it 0. So now there's only one value here, one variable, 4.5y, and that's equal to 13.5, and you just solve the linear equation from here on. It's also helpful to draw a line here so you don't confuse your variables with the numbers on the right side. And that's how you solve a linear equation using Gaussian elimination. So that's how you solve a linear equation. With these three methods, I think you'll be able to get through it all right. For simpler equations, like this one, you should probably stick to the first two methods because this looks quite complicated when you do it here. But for larger equations, this one can certainly be very helpful. So, thank you for watching my video. See you next time. Bye!